Let's talk about a comprehensive trig review. This is going to be part 3. So part 3, I am up to question number 26. Try to give you this in small doses. The next question, number 26, says find the secant of minus theta if theta is somewhere between 180 and 270. Okay, well, where's minus theta? If theta is between if theta is between 180 and 270, then minus theta must be between minus 180 and minus 270. Minus 180 is right here, and minus 270 is right here, so it's sitting here in quadrant 2. Okay, secant in quadrant 2 is negative. So that's the answer to that question. Next question, minus 403, what's the reference angle? Well, that's pretty easy to do with a calculator. Minus 403, I'm going to add 360. So here's the calculator. I'm going to just do it this way. So I've got minus 403. I'm going to add 360. Just go around the circle once. And that leaves me with minus 43. What's the reference angle of minus 43? It's 43. So there you go. Okay. 28. When sitting atop a tree and looking down at his pal Joey, the angle of depression of Mac's line of sight is 51 degrees 11 minutes. So here's Mac right here, and he's sitting there and he's looking down at Joey like this. Joey, okay, his angle of depression, that's that one, is 51 degrees 11 minutes. If Joey is known to be standing 32 feet from the base of the tree, so here's Joey, 32 feet from the base of the tree. How tall is the tree? Here's the tree. Okay, so let's take a look at that. This is really not part of the triangle, unless you want to go this way with it. You could put the tree here. I know he's not in that tree, but this line and this line are the same. These are similar triangles. This one is 5111, so you could do that. We need to find out how tall the tree is, okay? So if this is 51 degrees 11 minutes, then tree is opposite and the 32 feet is adjacent. So if we take the tangent of 51 degrees 11 minutes, we've got opposite, which is the tree, over 32 feet. Multiply both sides by 32 feet, and pull out the old calculator. Here we go. 32 times, I'm in degrees, so tangent of 51 degrees and 11 minutes. There we are. Now I was lazy, I didn't even close the parentheses. I've got 39.7762741 and on and on and on. Let's go to the nearest foot. So about, 40 feet. So he's up there pretty high, right? All right, so that's number 28. Let's check out number 29. Is this statement true or false? It's got sine of 390 degrees. So sine of 390 is equal to the sine of 120, the cosine of 270, plus the cosine of 120, sine of 270. Well, sine cosine plus cosine sine, that is the sine of the sum, 120 plus 270. That's an identity for the sine of a sum. 120 plus 270 is 390, sine of 390, sine of 390. That is true. okay? So, next one. Let's take a look at what I've got listed here as number 30. What's the solution to this? Secant of theta is equal to the cosecant of theta plus 46 degrees. Okay? How are secant and cosecant related? Well, they are co-functions of each other. So they are co-functions of each other. That means that they are each other's, the angles are each other's complements. Okay? So theta and this one should add, complements should add up to 90. So theta and theta plus 46 should add up to 90. So theta plus 46 should add up to 90. We'll subtract 46 from 90, you get 44. So 2 theta, theta plus theta is 2 theta, is 44 degrees. So theta is 22 degrees. So if you know how they're related, you can figure that out pretty fast. All right, next question. This one has to do with radians and a clock, the favorite, right? The question is, through how many radians will the hour hand of a clock go in 12 hours? Okay, well, let's check this out. Okay, so let's start our hour at 12. It's going to go 12 hours, so it's got to go here, 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 here. So it goes an entire circle. How many radians are in an entire circle? Well, it's equivalent to the circumference of a unit circle, so the answer would be 2 pi radians. So think about that a little bit. Okay, let's see some other things. What's 45 degrees in radians? Well, you take 45, you need to cancel degrees, so multiply by something over 180, the degrees will cancel. The equivalent is pi, so you get 45 pi over 180, which is pi over 4. Okay. Next one, 33. Let's see what this one is going to give us. Let's see. How do you find the cosine of 0.1209? Well, notice it does not have degrees written on it, so that's in radians. It's not an exact answer that we're used to, so I've got to go to radians, and so I'll do that. Okay, so I'm going to find the cosine of 0.1209, should be close to 1, 0.9927. Now, what if it said to do 4 decimal places? This has 4 also, but 0.9927. So we can kind of stop there. All right, so just a calculator question, not too big a deal. Let's check some other things that go with trig. The next question has to do with angular motion and that sort of thing. So question says that velocity is equal to the radius times omega, okay? And we need to find the exact answer. Let's see, this is 34. So the exact answer when r equals 16 centimeters and omega is equal to pi over 3 radians per second. So what's the velocity? Well, r times omega, v equals 16 centimeters over pi over 3 radians per second. Radians are kind of generic in a way, so that's going to actually drop out of this situation. But if I try working on this, this would be seconds per radian, which is kind of odd. Radians per second, okay? So let me just write this the opposite way. 16 centimeters, okay, times, now let me take 3 seconds over pi radians. So 3 seconds, pi radians. Okay. Now that looks pretty weird too. I needed to flip it over, which I did, and I was supposed to multiply it. That's where my problem is, isn't it? So it's got to be this way. Let me do this the other way. I'm not supposed to divide, I'm supposed to multiply. So times pi over 3 radians per second. There we go. This looks a lot better, so I've got 16 pi over 3 centimeters per second. There we go. Duh. Sorry about that. Okay. 35. Get my multiplication in there. This one says a pendulum is swinging through a central angle of 67 degrees. So we're back into degrees. It completes an arc length of 7.2 centimeters. So that's the arc length. And it says, what's the length of the pendulum? Length of the pendulum. Okay, formula for arc length. S equals r theta. R would be the radius, so that's the length of the pendulum. And theta is the angle, but in degrees. So, arc length, 7.2 centimeters. What's the radius? Don't know. What's theta? 67 degrees in radians. So 67 times pi over 180, just translate it. Now to get it over so that you've got to solve for r, let's multiply by 180 over 67 pi. 180 over 67 pi. And this one probably could be done with an estimate. So I'm going to take 180 times 7.2, divide by, now be careful when you divide here. I've got to put the whole thing in a package. So this, like that, 67 pi. If I don't, I will be multiplying by pi, not dividing. So I get r is about 6.157, 158, 395. Round it to the nearest hundredth, so 6.16. So 6.16, and everything here is measured in centimeters, so we'll use that. All right, get that up there so you can see it. Okay, let's check some other things here. This one says the cosine of s is equal to 1/2, and s is is in a region from 3 pi over 2 to 2 pi. Okay, closed region. Well, look at this reference angle. Cosine is 1/2 at pi over 3. Reference angle, 60 degrees, pi over 3, however you think. But this is quadrant number 4. So I've got to put pi over 3 and quad 4 in this form. Okay, so I'm going to have to take 2 pi minus pi over 3. This is 6 pi over 3 minus pi over 3, so s is going to have to be 5 pi over 3. So that's the exact answer. All right, next one. Let's try to figure this in radians. So 72 degrees in radians. So we're going to take 72 times pi over 180. Now something that your calculator does that's pretty slick, you might like this, is you can take 72 divided by 180, hit enter, hit math, enter, and it'll give you a reduced fraction, so 2/5. So this is going to be 2 pi over 5. Now I know you can do that in your heads, but that's kind of a nice feature of the calculator. All right, Next one is a word problem. Suppose the tip of a minute hand of a clock is 5 inches from the center of the clock. So the minute hand is 5 inches, okay? Determine the distance traveled by the tip of the minute hand in 5.5 hours. So 5.5 hours. Okay, so might as well start at noon, doesn't matter, but here it is. It's at the top of the hour. So goes around 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Okay, so five full cycles or circles, okay, plus 1/2, 5.5, okay, half of a circle. Okay, so there's your 5.5. 5.5 times the entire world here, okay? Well, S, arc length, equals R, 5 inches, times theta in degrees, in radians, excuse me. So what is 5.5 full circles in radians? Well, one circle is 2 pi, so 5 circles is 10 pi, plus a half circle is 11 pi. So we've got 11 pi. So we've got 11 times 5 is 55 pi inches. 55 pi inches. And the question says you leave in exact values, so I left the pi there.